Hi, in this tutorial I'm going to explain how to create a particle wall in Godot. First of all, we're going to need a 3D object. This object has to be animated. You can use Blender, GTScript, or maybe Godot Animation Player. Next, we need a plane, a mesh instance 3D. From this plane, we are going to obtain the deep map. Next is a camera to capture the deep map. And then we need a viewport to obtain the texture. And finally, we're going to use a texture inside the GPU particles. Once we have the deep map in a texture, we are going to sample it in some points, which corresponds to the grid of particles. Depending on the number of points, the resolution of the grid will change. We're going to do this with all the coordinates. As you can see, depending on the number of particles, it will be the number of samples we take from the deep map, and therefore will determine its resolution. I'm going to use this school model from Sketchfab, but really you can use anything. Of course, the animation will be different. This particular model doesn't come with animation, so I just added two bones, one for the top of the skull and the other one for the jaw, and manually added the parts of the mesh corresponding to each group. Finally, I added a very simple animation. So let's start by creating a new folder and importing the model. By double-clicking, we can configure it. In my case, I exported unnecessary geometry, and I am going to remove it. I will set the animation to loop mode linear and enable save to file. Now, I will position the model and make it local, so I can modify it. In the animation player generated automatically, we can set the animation, but I prefer to use the animation tree. I will use animation blend tree as tree root, and I will assign the animation player now. I will add a time scale node to control the speed of the animation, and I am going to activate the animation tree. Now, in the armature, I am going to assign a script to animate the skull. I just copy this script that animates the position and the rotation with the sine function. I will save the scene and reload. This way, you can see the changes in the animation. I will move back a bit, and I will add the plane needed to get the deep map. I will give it a size of 0.5 meters and align it right at the origin. Then I adjust the position of the skull a little bit. Now, I will assign a material shader to the plane and a shader. In this case, it will be visual shader. And then I will add a proximity fade node, which is a quick way to get the deep map. I will add a floating parameter to control it, and a 1- node to invert the color. Now I can adjust the depth, and I will also activate the unshaded checkbox. I will add a viewport and a camera that has the same size of the plane. In this case, it will be orthogonal to avoid perspective distortion that we don't need. We align the camera properly and make sure it is displayed in the viewport correctly. Now, I am going to move all the objects a little bit and align them again so I can put the particles in the world's origin. So I add the particles and also add a shader in the process material that I call world particles. I am just going to copy and paste the shader. It has several parameters, a remap function, and I don't use the start function. This part is used to create the grid, where we define the particle size with S, the columns, the rows, the column ID, the row ID, and with that I create a normalized space to be able to sample the depth texture. I get the texture in the variable D and then make some adjustments with the remap function. Then, scaled depth is used to change the depth proportionally with the width and the height. The variable center is the local space from where we are going to place the particles. We position each particle using the col ID and row ID for the X and Y plane and the depth for the Z-axis. Now I apply a transformation to each of the particles, which is the emitter transformation. This allows you to rotate all the particles at the same time. Then I copy the emitter rotation to each particle and multiply by the scale. The custom variable is used to send the data to the spatial shader of the particles. I am going to resize the particle gizmo a little bit. Now I will select the shape of the particle, in this case is a cube, and I will change the number of particles to some value. I will try with 100, and to distribute them I will change the resolution. I choose the D map from the viewport and you can see the result. I am going to change the resolution, and this number must be in proportion to the number of particles, otherwise something like this happens. I will select the appropriate value, which in this case is 900 particles. Obviously, it's better to control this with GDScript. I can change the way the deep map is captured in the plane. Since the proximity fade node is being used, this modifies the animation of the particles. Now I am going to create a new spatial shader to change the color of each of the particles. I am going to copy and paste the shader. I change the color. And I have to reload the scene to make it work. It has some parameters like the color, the emission color, and a curve to control the easing. Also, a variant to transfer the value from the vertex to fragment. Since this value is only available in the vertex. Now, I assign a curve to control the color interpolation. You can see how the color changed as I move the handlers of the curve. Now, I will assign a script to control the shader in a simpler way. It just sets the parameters and does a simple arithmetic calculation to assign the number of particles, as you can see in this line. So now I can change the size, the depth, and optionally I can change the proximity fade parameter. So I can change the way the depth is captured. So as you can see here, it's different. And this is the end.